All right, let's look at some transformations, and we're going to describe the transformations. All right, so here's the first one. Describe the transformations on f of x equals x squared to get the graph of the equation. So just remember how it was set up, right? F of x equals a, and we're not going to worry about b, so x minus h squared plus k. All right? So we're going to match this function. This was an x squared. All right, so the a is the coefficient, and I'll color code these. A is the coefficient in, I want E. Looking for a highlighter. Well, I guess I can't have a highlighter. I'll just underline it. Normally I can grab the highlighter. Ah, there it is. I don't know if you can see it. All right, so there's A. Notice that A is greater than 1. So that means that we have a vertical stretch by a factor of 2. It's negative, so there's a reflection in the x-axis. All right, so now we have, oops, I put down my pen. We'll do blue. We have this, that's not too bad. We have this minus 3 there. Actually, that's, all right, so x minus, there we go. X minus 3 means we are translating 3 units to the right. If it was left, it would be x plus 3. All right, and so that's this right here. Oops, let me switch colors. All right, so that's that blue right there. And then finally, we have a plus 5 added to the whole function. And I have no idea what, it's purple. Let's see. Oh, it's kind of dark. I guess okay though. All right, so that plus 5 means we're going to translate 5 units up. And I'll mark that in red. All right, so you should be able to determine all the different parts of our rule and what it's telling us about how our function is moving. All right, so let's do a little practice. Oops, I got this twice. A little practice. All right, here's the first one. I'm going to fill in the parent functions, and you try and quiz yourself by thinking what the answer is for the translation before I put it up. All right, so the first parent function, this is f of x equals x squared, because I have an x squared there. The second parent function, I'm just writing these in, we got absolute value, is g of x equals, and this is in your notes. Actually, so is that other page. G of x equals the absolute value of x. And then we have h of x equals the square root of x. And sorry, my cord is caught. There we go. I have to watch my cord that doesn't get caught. And we have another f of x for good measure. And so notice I have a cube here. This is x cubed. So now let's write down the transformations. All right, so in the first one, we see we have a minus 10. Not added to x, it's added to the whole function. All right, so what's that mean for our graph? It means our graph is going to translate 10 units down. So you try and think of them before I say them. See if you kind of like quiz yourself, informally quiz yourself. All right, so I've got a plus 2. It's inside the absolute value bars. So plus 2 means it's going to move 2 units to the left because it's added to the x. So 2 units left. Next one, we've got 2 transformations. The minus 1, x minus 1 is added to the x. It's a minus, so it's right. So it's 1 unit right. That plus 6, I added to the end there. All right, so that makes us go up and down. It's positive, so it's 6 units up. And the last one there, all right, we have x minus 4. That's 4 units right. And we have a minus 5 at the end, 5 units down. So just remember, if it's to x, it's right and left. X plus, that's left. X minus, that's right. add to the whole function. Notice it's not in the absolute value bars. It's not in the x squared. It's not in parentheses. All right, then it's up and down. Positive, it's up. Negative, it's down. All right, here's the next one. And here we're going to try to write the equation for the graph by plugging. So there's no, I will tell you on both of these, a is 1. All right, so notice we have the exact same width. If you look at the parent graph in blue there, it's if I go up 1 to the right 1, or up 1 to the left 1, notice I have a point there. The same thing here. To the right and up, to the left and up, I have the same point. So they're the exact same width. They're the exact same shape. Same thing over here. All right, so if I go 1 to the right and up, 1 to the left and up, 1 to the right and up, 1 to the left and up. Notice I've got the exact same size function. So a here is 1 for both. So we only got to worry about h and k. All right, so let's take a look. Our graph has a vertex, the one we're given at 0, 0. Our graph that we want to write the equation of has a vertex at 4, 1, 2, 3, yeah, 4, 3. So that means our graph moved 4 right and 3 up. So that means I need to replace the h with a 4, and I need to replace the k with the 3. So my equation will be y equals, and we'll drop the a because there's no point in writing a 1. Y equals x minus 4 squared plus 3. And there we go. And we'll spend a lot more time when we start graphing quadratics later this quarter. Let's look at the next one. Again, a is 1. They're the exact same shape, exact same size and shape. They're just in a new location. The vertex for the absolute value is at 0, 0. The vertex for our new absolute value function is at negative 1, negative 4. All right, so that means we need to replace negative, if you look here, we went 1 left, and we went 4 down. And both of those are negative, right? Moving to the left is to the negative side of the graph. Moving down is the negative side of the graph. We need to replace the h with a negative 1. We need to replace the k with a negative 1. So that gives us y equals, and we can drop the a, x minus a negative 1, and that goes in the absolute value bars, plus a negative 4. Let's get rid of these double signs and make it y equals the absolute value of x plus 1 minus 4. And there we go. We've written the equation for our absolute value graph. All right, so let's try to write some, actually, I might save that particular, we will do, I think that might take me too long for this video. Let's do this one, and then tomorrow in class we'll do this one. All right, so here we want to figure out the transformations. All right, now I said I wouldn't include any b values, but I do have some negative b's. Now the trick, and we really won't see b values until we get to radical functions in the 4th quarter. The tricky thing about the b value is you've got to factor it out. And I already did that for you. So in your notes, so these are some challenge problems. Well, at least numbers 1 and 3 are. In your notes, I'd like you to write down the factored form there. So I simply divided both of those values in the first one by negative 1. So instead of negative x plus 2, I have negative, and then negative x divided by negative 1 is just x. 2 divided by negative 1 is negative 2. So now I can figure out my transformations. This negative is inside the square. So that's on the x, that's a b. So b here is negative 1. if b is negative, it's going to reflect over the y-axis. Right? So it's really important for us to factor out that -1, because we might have thought our graph moves 2 to the left, when in fact it moves 2 to the right. And if we were to plug in values, we would not get a graph that moved 2 to the left. We'd get a graph that moved 2 to the right. So h is actually an x minus 2, or just 2. And our k is -1. So that x minus 2 means we're going to translate 2 units right. The -1 at the end means 1 unit down. All right, and let's just finish up the last 3 of these. All right, so number 2 is a little easier because there's nothing to factor out. The -1 in front, that's a. A is -1. That means we're going to reflect over the x-axis. Our our absolute value function is going to be pointing downward. It's going to be upside down. It's going to be the reverse direction. The -5 there, that means h is 5, right? Because it's x minus 5. Whoops. That means we're going to shift 5 units right. And the 1 at the end there, it's a positive. So we'll move 1 unit up. All right, I took care of number 3. I factored that negative out. All right, I can't take the negative out of the radical because the square root of, you can't take the square root of a negative number, but I can leave it in there. All right, so here, the 1 negative, this one is a. We have a negative on a. We have a negative in b. When we get to the 4th quarter, we'll graph something like this. But I did have to factor the negative out. All right, I have to have b by itself. I can't have b distributed. So if I pull the b out, if I pull the -1 out, negative x becomes x, 3 becomes -3. And we just divided by -1. So now our a is -1. That's a reflection over the x-axis. The b is -1. That's a reflection over the y-axis. So we'll fit everything in here. We have our h is 3, right? X minus 3. Maybe I'll leave the x minus 3 out because I'm running out of space. So h is 3 because the minus sign goes with the equation. That's 3 units right. And then k, we added 2. So that's 2 units up. That's about as complicated a graph as we'll graph in terms of radical functions in the 4th quarter. Let's look at the last one. This one's a nice, easy one. All right, so the negative in front, that's a, right? Because it's not on the x. It's in front of the whole thing. It's not with the cube there. So a is -1. That's reflect over the x-axis. And b is 1, so nothing there. And k is 0, nothing there, but we have an h. So h is 4, right? And it's an x minus 4, so that's 4 units right. All right, and that's where we're going to stop. Thanks for watching, and bye for now.